Hi, my name is Hamza Afzal. I'm an applications engineer for mixed signal products at Linear Technology. Protection against voltage transients is essential for the reliability of any system, from automotive to avionic applications. Protection against short spikes is done with filter capacitors and transient voltage suppressors. While these devices might be suitable for short spikes of limited energy, they are not adequate for the long transient surges found in many industrial applications. Let me show you. Here I have the LTC3810, a 100-volt current mode synchronous switching regulator controller with a 12-volt output driving a light bulb. I have the 1N6284A, which is a 1500-watt TVS across the input of the demo board. This TVS will act as my protection circuitry. I will apply a 100-volt pulse, and we will observe how the TVS protects the downstream circuitry by observing the input voltage with the aid of a scope. Make sure that you have proper protection before turning power on. Here is the setup on the bench. Notice the light bulb indicates power good. Now I'll send a surge with the help of a pulse generator. The light bulb turns off, indicating that power was lost. Let's take a look at the scope to see what happened. The voltage seen on the screen is the voltage across the TVS. Notice how the TVS barely manages to protect the buck converter for a few microseconds before it fails as a short circuit. If the surge was big enough, it could have blown open and taken out the downstream circuitry along with it. Stringing multiple TVS devices together in parallel would improve the ruggedness of this protective circuit, but to extend protection to even a millisecond might require 1,000 devices, which is totally impractical. Linear Technology has a new type of part called a surge stopper that protects downstream circuitry from surges which last from microseconds to DC. The LTC4366 surge stopper works by normally passing the input to the output with low loss. But if the input rises too high, it regulates the output at a safe level. The LTC4366 operates in a floating topology, making it capable of suppressing transients of virtually unlimited voltage. The output voltage is regulated by controlling an external N-channel MOSFET. Once the output reaches the regulation voltage set by the resistor divider at the feedback pin, the timer runs for a predetermined time, which is set by the value of the timer cap. After the timer expires, the LTC4366 turns off the MOSFET in order to protect itself. There is also a shutdown pin so that the LTC4366 can serve as a switch to turn the load on and off. Now let's take a look at the protection circuit of the LTC4366 in place of the transorb. I'm going to be using the standard demo board of the LTC4366. The clamp voltage is set at 43.1 volts. Now let's take a look at the LTC4366 in action and use it to protect our downstream buck converter. Let's send the same 100-volt pulse that blew up our TVS and see how the LTC4366 holds up. Notice how the light bulb stays on. Let's take a look at the scope. The input waveform is on channel 1. Notice the 100-volt square pulse for 30 milliseconds. The output waveform is on channel 2. Notice the flat region in the waveform where the LTC4366 is regulating the voltage at our desired clamp voltage of 43.1 volts. It is protecting the downstream converter and regulating for 100 times longer than the TVS without failing. In this case, we chose the timer cap such that it can ride through a 100-volt 30 millisecond surge without tripping off. Now that's all well and good, but what if someone plugs in a sustained overvoltage? Let's connect the LTC4366 directly to the 100-volt power supply. The LTC4366 also protects the downstream circuitry against DC overvoltage conditions. The amount of time this condition can be tolerated is dependent on the safe operating area of the MOSFET, and so is not unlimited. In this case, the LTC4366 protected itself as well as the downstream circuitry by shutting off. The TVS in this situation would not stand a chance. Once the fault goes away, the LTC4366-2 turns the power back on. As mentioned earlier, the LTC4366 can operate at very high voltages due to its floating topology. Let's demonstrate the LTC4366 operating at 200 volts DC and withstanding a 300 volt input surge. I have made the appropriate modifications to the LTC4366 demo board, and it is operating at 200 volts DC at 1 amp. I will now send a 300 volt surge pulse into the circuit to see how the LTC4366 holds up. No problem. The LTC4366 regulates at 210 volts and withstands the 300 volt surge easily. This kind of flexibility is not available in traditional protection schemes. In conclusion, the LTC4366 is a rugged high-voltage surge stopper which can be used in a wide variety of applications, from an operating voltage of 9 volts to hundreds of volts, limited only by the breakdown voltage of the MOSFET. It is the perfect solution for many industrial, automotive, and avionic applications. Visit us at Linear.com for more details. Thank you for watching.